Hello, I'm Dr Sergis from the Dr Sergis Academy, and today I'd like to do another video on solving logs for A-level mathematics. So these are a set of questions that you'll get typically from any exam paper, whether it's NXL, OCR or AQA. And so if you look at the actual questions, we want to, in the first one, we want to express this particular expression as a single logarithm. Okay, so first of all, remembering what we did in the last video. Okay, so remembering that, just to remind you, log of a number, let's say the factors of that number is AB. So it could be any log. So ln represents log to the base e. E is an irrational number that is used very often to solve mathematical problems, especially in A-level and beyond. So it's log to the base e, which is somewhere between 2 and 3, and it's an irrational number, a bit like pi. So if I put ln AB, that's the same as the sum of the logs of the individual factors. I mentioned that in my last video on solving logs, number expressions with logs. So the second generalization is when you've got log of a quotient. Let's say A and B, A is the numerator, B is the denominator. Yeah. So that will be the same as log of the numerator minus log of the denominator. So these generalizations are true for any log, because we're dealing with log to base e, so we'll put ln. ln is short for log to base e, which can also stand for natural logs, because e occurs quite often in nature and solving problems, so we call it a natural log. And log of a to the power of b equals n times ln of a times log of a. Okay, remembering these generalizations, we're going to use one or more of these in order to solve that particular problem. So let me write down what the question is for part A, which is, that's question 4, part A, in that mathematical A-level maths question, in that first line. So we know that's 3 ln, which is log to the base e, as we said, of x minus 2 ln y plus ln x plus 1. Okay, so first and foremost, if we now convert this, which is, remember, that's n, and then you can write it over the log of the number as an exponent, as a part. So that will be, that's one of our 3 results that we just summarized. So that's the same as, that's your n, and that becomes the exponent of the power. Minus, again, the same thing here, ln y squared. Okay, so that will be the coefficient, becomes the power, and that's ln x plus 1 collectively. Now, so this would be, this would then be a quotient. That's like log of a minus log of b. So that would then be ln of x cubed over y squared. Okay, again, that's one of our results that we generalized a moment ago, plus ln x plus 1. And of course that will be, remember the first result, that's a, that's b, so therefore we can say that's log of x cubed brackets x plus 1 over y squared. So that will be the actual answer to question 4a. So it'll be log of this whole expression in brackets, x cubed times x plus 1, or divided by y squared. So that's the answer to the first question. Now let's address part B. Okay, so part B, we want to actually solve to find the unknown x. So we've got in part B, so question 4, part B, in part B, we've got 5 to the power of x equals 100. Okay, so we take logs on both sides. So when you've got a number with the exponent, with the power, and the power is the variable, that is, the power is the unknown, we're going to solve that, then you take logs on both sides, any base log. But typically for A-level maths, we use log to the base e, which is ln, or natural logs. So we take logs on both sides, and what you do one side just on the other. And this is also true, of course, for logs. So log ln 5 to the x equals ln 100. So we take logs on both sides, and that becomes our exponent. That will be n. So that will in is x, as it were, and then 5 equals log of 100. And therefore x, by transposing or solving the equation in the normal way, so therefore the answer would be log of 100 divided by log of 5 to the base e. And that would give us, we do the calculation, it's asking us to 3 decimal places, so it would be 2.861. Okay, and that would be the answer of part B. Okay, now let's address the final question. Yeah. Okay, so it says solve the equation of ln log to the base e of 2x plus 3 equals 4. Give your answer 3 decimal places. We're going to find x here. So let's write down the question. And so we've got ln, which is log to the base e of 2x plus 3 equals 4. Okay. So remember the definition of log. Yeah. So just to recall, log to the base a is any base. It's an integer of x equals y. So it's asking us what power do I raise a to get x. Therefore, a to the power of y is x. So we raise a to the answer, which is y, and then you get x. Yeah. So that's what we're going to do here. So it's so here ln means ln is short for log to the base e, which is natural logs. Yeah. So it's asking us what power do I raise e to get 2x plus 3. That would imply e to the power of 4 is 2x plus 3. So from the log, we can end up with in one step with a situation where we remove the log by definition, because it's asking us what power do I raise e to get that is e to the power of 4. Okay. So all we do is just transpose the equation, just solve it. Therefore, 2x, taking away 3 on both sides, of course, e to the power of 4 minus 3 is 2x. Therefore, x equals e to the power of 4 minus 3 over 2. Okay? And then if we evaluate that, we get, with the calculator, we get 25.8, yeah? And it's asking us to 3 decimal places, yeah? So if I do the calculation to 3 decimal places, okay? So it'll be take with 3. So that would be, so to 3 decimal places, that's 3 single figures. To 3 decimal places would be 25.799. Yeah, to 3 decimal places would be 25.799. Okay, as required. I hope you enjoyed that. Thank you.